Which parts of the sky can the Webb telescope see? The James Webb Space Telescope orbits the Sun in sync with Earth, but 1 million miles further out, beyond the Moon. The telescope's mirror is perpendicular to the 70-foot sun shield, which keeps it cool. The telescope's movement is limited in certain directions to keep the mirror and scientific instruments in the shade of the sun shield, blocked from the heat of the sun. But Webb can rotate to get a 360-degree view of the sky. As Webb orbits the Sun, different celestial objects enter its available field of view. Science observations with the telescope will be carefully scheduled to make the most effective use of Webb's time. Over the course of 6 months, Webb has access to the entire sky. Allowing astronomers to investigate a range of questions about how the universe works and our place in the cosmos. How do we learn about a planet's atmosphere? How do we know what's in the atmosphere of an exoplanet? The majority of known exoplanets have been discovered because they partially block the light of their host star. This is called a transit. During a transit, some of the star's light travels through the planet's atmosphere and gets absorbed. The light that survives carries information about the planet across light years of space where it reaches our telescopes. However, the planet is very small relative to the star, so it is still very difficult to detect, which is why we need a big telescope to be sure to capture this tiny bit of light. So how do we use a telescope to read transit light? Stars emit light at many wavelengths. Like a prism makes a rainbow, we can separate light into its separate wavelengths. This is called a spectrum. Visible light appears to our eyes as the colors of the rainbow, but beyond visible light, there are many wavelengths we cannot see. Now back to the transiting planet. As light is traveling through the planet's atmosphere, some wavelengths get absorbed. Which wavelengths get absorbed depends on which molecules are in the planet's atmosphere. For example, carbon monoxide molecules will capture different wavelengths than water vapor molecules. So when we look at that planet in front of the star, some of the wavelengths of the starlight will be missing, depending on which molecules are in the atmosphere of the planet. Learning about the atmospheres of other worlds is how we identify those that could potentially support life, bringing us another step closer to answering one of humanity's oldest questions: are we alone?